So, good morning, sir. So, I am GR Migatuan. So, in this video, I'm going to explain my PowerPoint presentation about the common damages defects that may occur on watertight transverse bulkheads situated in the ends of dry cargo holds of a bulk carrier. So, let's start it. So, what is the main problem that may cause defects or damage on water type at the bulk carrier? Or sa bulk at the bulkhead. So, the main cause is the excessive wasted corrosion, in particular at the mid-height and bottom of bulkheads, which may lock in deceptively good condition. So, these are the following examples of the more common damage or defects that may occur. So, there are three. So, fractures, buckling, and excessive. So, fractures at the boundaries of corrugations and bulkhead stools, particularly in way of shelf plates, sheather plates, deck, inner bottom, and etc. Buckling of the plating corrugation leading to failure of and collapse of the bulkhead under water pressure and an emergency situation. Excessive wastage or corrosion, in particular at the mid-height and bottom of bulkheads, which may lock in deceptively good condition. This is created by the corrosive effect of cargo and environment, in particular when the structure is not coated. So in this, social attention should be given to the following areas. Bulkhead plating adjacent to the shell plating. Bulkhead trunks which form part of venting, filling, and discharging arrangement before or between the top side tanks and the upper tanks. Bulkhead plating and weld connection to the lower or upper stool shell plates. Weld connection of stall plating to the lower or upper stool shelf plates and inner bottom. In way of weld connections to topside tanks and upper tanks. In any areas where coatings have been broken down and there is evidence of corrosion or wastage. It is recommended that random of thickness determination be taken to establish the level of diminution. Other structures, diaphragms inside the stools, particularly at their upper and lower weld connections. So it have actions that we would take as a chief officer or crew to avoid the detrimental effects of bulk carrier due to corrosion, fatigue, and improper cargo handling. Factoring of the structural members of the transverse bulkheads of a bulk carrier. So there are four. So first is the side shell plating. Second is the connection of the bulkhead plating to the side shell. The third is connection of the side shell frame and end of brackets to the shell plating and upper side tank plating of the closest up inspection. The last is connection of side shell frame and end brackets to the shell plating and top side tank plating. So, actions to control structural stresses and fatigue. So, there are 5 actions. So, first action is routing, plan, maintenance, inspection of the structural members of the cargo holds and hatch covers. Second is identification of susceptible areas prone to fatigue and stresses. Third is ensure accessibility of the area to be surveyed when the regards to the area under inspection shall be clean and well lit. The fourth is careful planning of the surveys to be undergone with all personnel involved. The last is when a fracture which not been caused by a contact damage is found in the main hull structure on one side of the ship. Corresponding structure on the opposite side should be examined to see if a similar fatigue has occurred. Fractures of the nature are of concern, especially where corrosion is associated with failure and may have been contributing factor. So there are 10 structural surveys that we have or include. So the first survey is routine inspection, planning surveys, surveys of non-defects, classification surveys, annual surveys, intermediate surveys, special surveys, condition surveys, CEP cap surveys, and the last is life extension surveys and etc. So fatigue cracking of steel structures. So fatigue cracking occurs at points such as hatch covers where stresses are locally high. Such cracking is the result of the cumulative damage caused by cyclic loading of structure and invariable starts at welded joints. The fatigue life is the time required in the service for the structure to experience enough stress cycles for a crack to occur. A bulker is so designed that with proper maintenance, cracking should not occur until a fatigue lifespan of 20 years. Fatigue lifespan, once used, it cannot be regained except by the complete replacement of welded joints. Therefore, it is very essential that the welded joints of an overstressed structure are replaced before proceeding with live exterior surveys or programs. Fatigue cracking have been most frequently observed in the bracket toes at the connection of the main frames to the hopper and topside tanks, and in the boundaries of the vertically corrugated transverse bulkheads with upper stools, lower stools, and topside stools or topside tanks. So, corrosion or structural deterioration. So, the major barrier preventing structural deterioration of ships, especially in every corrosive environment of water ballast tanks, and to a slightly lesser extent cargo holds the tank and or hold coating. Since the establishment of ASP is yun, survey program yun. Yung nakalimutan ko yung E. Basta ganun, survey program to. Tapos water ballast tank and CH of all new ships must be fully coated, such as should be hard coating, probably light in color. So, importance of assessing defects and damage to cargo spaces is it is important that the protective coatings in cargo holds and water ballast tanks are maintained. Therefore, it is imperative that the cargo holds and deck areas should be inspected by ship's deck officers upon completion of cargo operation to identify any signs of physical damage, corrosion, or coating damage to the ship's structure. And where hull damage is identified, which may affect the integrity of the hull structure and seaworthiness of the ship, it should be reported accordingly to the classification society. And other is the internal hull structure and protective coatings in the cargo hold and adjacent double bottom spaces are vulnerable to damage when the cargo is discharged by using grabs. Grabs are made from uh, toughened steel material, and when carelessly used can cause considerable damage to ship's structure. And the other um, importance is chipping or sharp indentations and the local buckling or detachment of side frames and end brackets at lower connections could lead to cracking of the side shell plating, which would allow the ingress of water into the cargo spaces. The other important is the protective coating, which may be required to be applied in the cargo hold, are also subject to deterioration caused by the corrosive nature of the cargo. High temperature cargo settlement during the voyage, and abrasive action of the cargo. So the last is corrosion will weaken the ship's structure and may eventually seriously affect the ship's structural integrity. The severity of the corrosion caused by a structural member may not be easily detected without close-up inspection or until the corrosion causes serious structural problems such as collapse. Collapse is tumba. Tumba lang. Detachment of the hold frames. Mga huso. Ang mga hold frames or resulting in cracks and propagating in a side shield. Side shield. Ang mga cracks sa gilid-gilid. So that's all, sir. Thank you.